Today, we're digging into the mind of Steve Wozniak and the systematic philosophy that led him build something that, well, literally didn't exist yet. This isn't just a story about a computer. It's a story about a way of thinking. It's about a quiet genius who saw a future no one else could, and then meticulously engineered it into reality with a kind of discipline we can all learn from. And it all starts at a time when the idea of a personal computer was basically science fiction.
So, picture this. The year is 1975. Steve Wozniak, he's an engineer over at Hewlett-Packard, totally obsessed with electronics, and he's staring at a simple, stark reality. Personal computers, they just didn't exist. And I don't mean they were rare, I mean the very idea was a total void in the collective imagination. See, the prevailing wisdom, what all the experts agreed on, was that computers were these massive, ridiculously expensive mainframes that were only for the government or giant corporations. The idea that a regular person could have a computer on their own desk for their own stuff, it sounded absurd. And it was right there in that world of impossibility that Wozniak had his big aha moment.
To really get what a huge deal this was, we have to put ourselves back in that world. So let's take a quick trip back to the mid-70s and just look at what computing actually meant. It wasn't just a little different. It was a completely different universe of technology.
Okay, so check out the contrast here because it is just wild. On one side, you've got the mainframe. I mean, these things were giants, owned by huge companies and universities. They cost millions of dollars, filled up an entire air-conditioned room, and were run by this special class of technicians and lab coats. You couldn't just use one. You'd hand over a stack of punch cards and maybe, if you were lucky, get a printout a few hours or even days later. Then, on the other side, you've got Wozniak's vision, which was so radical it was almost funny. A computer for people, something you could actually afford, something small enough to put on your desk. It wasn't about making a smaller mainframe, it was about inventing a whole new thing entirely. And that right there shows you the kind of wall he was running into. This wasn't just a matter of opinion, it was an entrenched belief system. It was the industrial dogma of the day. All the money, all the experts, all the R&D, it was all pushing towards bigger, more powerful machines for big institutions. The idea of a personal computer was seen as a fun little hobby, a toy, with no real-world use or, commercial future. So Wozniak wasn't just fighting technical problems, he was fighting a total failure of imagination from the entire world. He had to build something the world didn't even know it was missing yet.
So how in the world do you do that? I mean, really, how do you build something that doesn't exist when everyone around you is telling you it's impossible and a waste of time? Well, for Wozniak, the answer didn't come from some fancy R&D lab with a huge budget. It came from a personal revelation, a huge breakthrough in how he thought about design itself.
This was the moment. The light bulb went off, and it wasn't just some fuzzy idea, it was a very specific technical insight. He realized that through pure, beautiful, elegant engineering, he could create a machine that actually worked with a shockingly small number of parts. By committing to radical simplicity, he could just bypass all the corporate complexity and crazy costs that kept computers away from regular people. This wasn't just a design choice for him, it became his mission. The road to revolution wasn't going to be paved with more power, but with a relentless, systematic stripping away of complexity.
Now, this obsession with simplicity didn't just pop out of nowhere. It was forged by his life. From the time he was a kid, he was obsessed with electronics, always taking things apart to see how they ticked. His dad, who was an engineer, drilled this powerful idea into him, that good engineering was clean, it was systematic, it was understandable. He taught him that a design is perfect not when you can't add anything more, but when you can't take anything else away. But maybe the biggest influence of all was scarcity. Computer parts back then were incredibly expensive. Wozniak didn't have a corporate credit card. He had his own paycheck. And that financial pressure forced him to become a master of minimalism. He had to figure out how to make one single chip do the work of 3 or 4. For Wozniak, necessity wasn't just the mother of invention, it was the crucible that forged his genius.
And this is really the key lesson from his early days. Building the future wasn't about cramming in more features, it was about a ruthless, systematic process of removal. He had to strip away every single non-essential part, every bit of confusing complexity, every unnecessary dollar, until the idea was so pure it could actually change the world. That disciplined reduction? That wasn't a compromise, that was the whole strategy.
So this way of thinking, it wasn't just a one-time trick. It became his entire philosophy. This personal revelation, born out of his history and his limitations, it hardened into a solid, repeatable principle, a framework for innovation that we can actually define and study today.
And here it is, the Wozniak Principle. And I want you to notice the key words here, systematic belief. This wasn't some lucky accident or a random spark of inspiration. No, it was a deep conviction that the highest form of engineering, the most powerful kind of genius, is elegance. And for Wozniak, elegance had a very specific definition: getting the absolute most function out of the absolute fewest parts. It's a philosophy that treats design like an exercise in purity and ruthless efficiency.
So this principle, it really stands on three powerful pillars. First up, the Component Minimization Mandate. This was his obsession. He was laser-focused on using the absolute fewest integrated circuit chips. Those are the little electronic building blocks, always asking himself, can I do this with one less chip? This forced him to invent completely new ways of designing circuits that other engineers literally thought were impossible. Second, the end-user empathy rule. He wasn't designing for other engineers in some lab. He was designing for his friends, for regular people. He wanted them to be able to use it, to understand it, and crucially, to afford it. That empathy was a core part of the design, not some afterthought. And third, the Open Architecture Doctrine. Now this was just pure strategic genius. By designing the Apple II with expansion slots, he basically invited the entire world to come help him build his platform. He guaranteed its future by making it something other people could build on top of, creating a whole ecosystem before that was even a buzzword.
Okay, so a big philosophy is great and all, but what does that actually look like day to day? How did he turn this big idea into, well, actual stuff? Wozniak developed systems and habits that turned his principle into a machine for producing breakthroughs. This is where the magic becomes a repeatable method.
His main system was something we can call the single-pass design protocol. And this is just incredible. His personal routine, his challenge to himself, was to solve the problem perfectly and elegantly on the very first try. There was no, we'll fix it later, or we'll patch it in an update. And the way he did it was by forcing each component to be a multitasking genius. A single chip might handle the system timing, help create the video signal, and process what you type on the keyboard. Three totally unrelated jobs. It's like having one person on your team who's the accountant, the graphic designer, and the head of marketing. It's insane efficiency. He was literally compressing complexity right into the hardware.
But he didn't do all this in a vacuum. His other core habit was this powerful feedback loop. First, he'd do this deep, focused design work all by himself, where he could get into that state of pure concentration he needed. Then, right away, he'd take his prototypes to the Homebrew Computer Club, this kind of chaotic, super brilliant group of fellow electronics nerds, and get instant, unfiltered, and very technical feedback. So you have this amazing cycle, intense solo work, followed by immediate, rapid-fire stress testing from the community. It was the perfect blend of solitary genius and collaborative polish.
So what was the ultimate result of all of this? We've got the philosophy, we've got the systems, we've got this relentless drive for simplicity. Where did it all lead? Well, the result wasn't just a successful product, it was a full-blown revolution that totally reshaped the world we live in.
You can see the whole story play out right here on this timeline. It all kicks off in 1975 with that impossible idea, just a spark in one person's head. By 1977, the Apple II is born. It's the Wozniak Principle made real, a thing you could actually buy and put on your kitchen table. Then, in the 80s, his big bet on open architecture pays off in a huge way. It fuels an entire industry of companies making software, games, and add-ons for his platform, which makes the machine more and more valuable. And today, just look around. His legacy is the very device that's probably in your pocket or on your desk right now. The DNA of that simple, elegant, user-focused machine is in basically every personal device we use.
And in that process, Wozniak himself was completely transformed. He went from being this brilliant but kind of shy, unknown engineer tinkering away in a garage to a global icon. He became the living proof that systematic, technical simplicity, when you combine it with real empathy for the user, could beat all the conventional wisdom and corporate complexity in the world. He didn't just build a computer, he built the future.
And this is where we bring it all home. Because the Wozniak's Principle isn't just a history lesson about some old computer. It's a timeless blueprint for innovation that you can apply to your own work, whatever it is you do.
The real question his story forces us all to ask ourselves is this. In our own projects, in our own challenges, how do we find our elegant solution? How do we cut through all the noise, the clutter, and the complexity to get to that pure, powerful core?
Well, the answer is to apply his methods. First, systematically audit your work. Really look at every single process, every feature, every step, and ask the hard question. Is this absolutely, fundamentally necessary? Second, you have to be ruthless about getting rid of what isn't. This is his component minimization mandate, but for your own work. It's not about making something worse, it's about making it stronger by removing all the hidden complexity. And finally, commit to that feedback loop. Don't hide what you're working on until it's perfect. Share it, test it, and use the direct, honest feedback of the people you're trying to serve to find the most elegant way forward.
In the end, Steve Wozniak's legacy is built on the profound truth that simplicity is the ultimate sophistication. The Wozniak Principle gave us a systematic blueprint to build what doesn't exist yet, not by adding more, but by bravely taking away. He showed us that the path forward is paved with component minimization and technical elegance, and his relentless pursuit of purity teaches us an unbreakable rule. In any field, true genius is never measured by complexity, but by clarity. Simplicity is the ultimate measure of intellectual mastery.